So the last method of soil exploration is indirect method, and it includes sounding or penetration test. So we can discuss about standard penetration test, and the sampler for this standard penetration test or SPT is split spoon sampler. Okay, so using the split spoon sampler we are collecting the soil sample using the SPT setup. So standard penetration test is also known as SPT. So this is the experimental setup, and the standard penetration test is most commonly used in situ test. That is, this experiment is usually conducted in the field. Okay, so it is in situ test and is used for coastal soil which cannot be easily sampled. That is, the sampling of coastal soil or sandy soil somewhat difficult by our usual method. So for that type of sample, we are doing the SPT test in the field itself. Okay, and the test is used for calculating the relative density and the anglo-shearing resistance of coastal soil, and it can be also used to determine the unconfined compressive strength of cohesive soil, and these all experiments are done in the field. Okay, so it is a field test in order to estimate the penetration resistance of the soil, and the standard penetration test is conducted in a borehole using split spoon sampler that we have discussed. That is, the split spoon sampler is used for doing the SPT test. Okay. And the dimensions of split spoon sampler, 50.8 mm outer diameter and 35 mm inner diameter, and minimum 600 mm or 60 centimeter length. Okay, and here the sampler is driven into the soil. The sampler is driven into the soil by a drop hammer of 63.5 kg weight, 5 kg mass, falling through a height of 750 mm at the rate of 30 blows per minute. So the hammer blow rate is 30 blows per minute, and the hammer blow height is 750 mm or 75 centimeter. And the number of hammer blows required to drive 150 mm of the sample is counted, and the sampler is further driven by 150 mm, and the number of blows is again determined. Likewise, the sampler is once again further driven by 150 mm, and the number of blows recorded. And so up to this I have told we are counting the number of blows for 150 mm depth for 3 times. Okay, and the number of blows recorded for the first 150 mm is disregarded. That is, the number of blows recorded for the last 150 mm interval are added to give the standard penetration number or N value. Okay, or in other words, the standard penetration number is equal to the number of blows required for 300 mm penetration beyond a seating drive of 150 mm. So that is standard penetration number. So the standard penetration number is equal to the number of blows required for 300 mm penetration beyond a seating drive of 150 mm. So initial 150 mm drive is neglected, or that is taken as seating drive, and after that we are counting the number of blows for the next 150 mm and also another 150 mm. So total 300 mm penetration is required, and the number of blows for this 300 mm penetration is noted, and that is taken as standard penetration number, and it is represented by capital letter N. Okay, that is standard penetration number N. And there is one correction needed. That is, if the number of blows for 150 mm drive exceeds 50, that is, if the number of blow N is greater than 50 for 150 mm drive, it is taken as refusal and the test is discontinued. Okay, so standard penetration number is corrected for dilatancy correction and overburden correction. So first one, correction for overburden pressure. So for coastal soil, correction for overburden N dash. N is the observed penetration, standard penetration number N. So we have to do correction on this N. So it is corrected one is N dash. Correction for overburden pressure. N dash is equal to 0.77 log to the base 10, 2000 by Q into N. So that is corrected penetration number N dash. Okay. So and this Q is the effective overburden pressure. And next is correction for dilatancy correction. Correction for dilatancy. That is, the dilatancy correction is calculated for the corrected n value, that is n dash. That is, we are doing the correction for this n dash. Okay, so it is that correction is marked as n double dash. So this corrected one n dash, if this n dash is greater than 15, n double dash, that is the correction is like this, that is 15 plus 0.5 into n dash minus 15. And if that is less than 15, no correction is needed, that is n double dash, corrected one is equal to same as this one. Okay, so this is for fine sand and silt below the water table. So it will be clear by doing one problem. Okay, so this is the correlation of SPT value for coastal soil. That is, this table shows n value. That is, if the n value, that is SPT value, is between 0 to 4, it means very loose, and 5 angular shearing distance, this table shows 5 value, 5 is less than 28 degree. And if the n value is between 4 to 10, it indicates loose, and 5 value is between 28 to 30. Likewise, we can relate the SPT value with the properties of coastal soil like denseness and angular shearing distance. And this correlation of SPT value for cohesive soil, that is, in the cohesive soil, we can relate this by unconfined compressive strength. That is, if the n value is 0 to 2, that means that cohesive soil is very soft and QU is less than 25. And if the n value is between 2 to 4, it indicates it is soft and the QU value is between 25 to 50. Like that, we can relate the n value for cohesive soil and coastal soil. That is, for coastal soil, it is related with the relative density and angular shearing distance. And for cohesive soil, that is for clay soil, this n value is related with its consistency and unconfined compressive strength. Okay, so this is about standard penetration test. So I'll repeat, the standard penetration test, the standard penetration number is equal to the number of blows required for 300 mm penetration beyond a seating drive of 150 mm. So altogether there is a penetration for a depth of 450 mm, and initial 150 mm penetration is neglected, that is, it is taken as seating drive, and the next penetration for 300 mm depth, that is 2 times 150 mm. 2 times 150 mm penetration after the seating is taken as penetration number, that is, the number of blows for that 300 mm penetration is taken as standard penetration number. Okay, so this is about standard penetration test, and we can do 2 problems based on the correction. Before that, we can discuss the advantages and disadvantages of SPT standard penetration test. Advantage means this experiment is relatively quick and simple to perform, and the equipment and the expertise for the test is widely available, and it provides representative soil sample because we are doing the experiment on the field itself, so the soil sample will not be disturbed. And N is correlated with the most properties of the soil, such as friction angle, undrained cohesion, density, etc. So it is very applicable and provides useful index for relative strength and compressibility of soil, and it is able to penetrate dense and stiff layers. And the result of this SPT test reflect soil density, fabric, stress, strain behavior, etc. And numerous case histories available. So these are the advantages. Disadvantage means it requires the preparation of a borehole. That is one of the disadvantages. That is, we have to prepare a borehole, and after that we have to do the experiment. So it is somewhat tedious. And dynamic effort is related to mostly static performance. And the standards regarding energy not uniform. Standards regarding the energy is not uniform. And if there is any hard stone, it is difficult to obtain reliable result, and the test procedure is tedious and require heavy equipment, and not possible to obtain properties continuously with depth. So these are the disadvantages of SPT test. Next is problem. A SPT is conducted in a sand deposit at a depth of 20 meter. Sand deposit for a depth of 20 meter. Water table is ground level. If n value is 40, find the corrected n value. Standard unit weight of the sand 19 kilonewton per meter cube, unit weight of water 10 kilonewton per meter cube. Okay, so here the SPT test is conducted on a sand and the depth of that sand deposit is 20 meter. We have to do the corrections, and the water table is at ground level, so we can neglect so we can consider, so we have to consider as submerged unit weight, so that is equal to saturated minus unit weight of water. So the whole soil will be in submerged condition, so gamma dash is equal to 9 kilonewton per meter cube. And first we have to do overburden correction. So for that, effective overburden pressure Q is equal to gamma into D. So here, since it is submerged, we have to take gamma dash into depth 20 meter, that is 9 into 20, 180 kilonewton per meter square is effective overburden pressure. And correction for overburden pressure, that is corrected N value N dash, is equal to 0.77 log 2000 by Q. So Q we have obtained as 180 and N is 40, that is the initial N value 40. So it is corrected one 32.2. Since it is number, we have to round. We cannot return as 32.2, so it has to be rounded as 32. Okay. So this and it should be less than 2n. 2n means 2 times 40, that is 80, less than 80, so it's okay. Next we have to do correction on this one. Not for next correction means correction for dilatancy. So we have done overburden correction. So the now our SPT value or corrected value is 32, SPT number, and we have to do correction on this 32, not for this 40. Okay, so it is N double dash. So N double dash we have to calculate and should be on N dash. So here N dash is 32. Okay, and correction for dilatancy means dilatancy correction equation is like this. That is, if this N value is greater than 15, we have to put this equation, and if it is less than 15, no correction needed. And here it is 32, which is greater than 15. So the correction equation is 15 plus 0.5 into N dash minus 15, and N dash is 32 and it is 23. So it is the corrected N value. Okay, so I think it's clear. Like that we can do some more problems. That problem I will put in the next video. Thank you.